Okay, so now we're ready to actually test this controller. I'm going to start with overriding the mouse and keyboard functions. Um, Normally, I would do that in PowerShell, which is just basic Windows control. So it's very easy to redirect an input to any software running on my Windows 10 machine here. But I think more people are probably familiar with Python than PowerShell. So for the videos, I'll do it in Python, and then for my actual usage, I'll convert that logic into PowerShell because logically, how our algorithm works is still the same. It's just a different syntax for the language. But I think more people are familiar with Python, so we'll look at that. And mostly the mouse input, because for a keyboard, I'm thinking we can just use the regular soft keyboard. The There are nicer ones. I'll look around, find one to install because I kind of like the swipe texting. I think the swipe text will go a little bit easier on that. I think I can install the regular Gboard. That's what I always install on my Android devices and use that instead. But I'll at least change the settings to do the hover text so that when the mouse pauses over a letter, it types. So we don't necessarily, so like move, then pause, and move and pause, and type that way. I think that'll work, but I'm going to see if I can find a regular input that'll do the swipe text. And so that will just be starting that software and running that. As far as the Python code, there are two main objects we'll use, and I pulled up the documentation here. Just a quick Google search, and you can get right to the API documentation for PySerial. So this is the standard, the basic Python library for serial communication ports. So if we go to the API here, there's instructions on how to install it and everything if you need it, but it's just the same way we always install Python modules, just pip-m, then the name of the module, and it'll bring it right in. So our main class that we'll use is the serial library, the serial object. And then we can say what port it's on, the baud rate it's transferring at. We'll definitely need those two, and the rest of these are optional. We're coming from a nano, so we're using just regular bytes. Parity checking if you need that, different things. Timeouts can be useful. We might use timeout. I think to start with, we'll just do the port and baud rate and keep everything else as the default because we know on my machine it's on COM6 and the baud rate was 115/200. Your machine, if you're following along, might have it on a different port. But then once we create that serial object, if we scroll down here, there's a read method. There's also a read line. We'll probably use read line and a write method. So we'll just write our command lines, write our command words, and send those down the serial port. And then somewhere down here, I believe there's a read line. It'd be a lot easier if this was in alphabetical order. Oh, there it is. And so we'll do serial.write and serial.readline to send and receive the commands to the controller. And then along with that, once we get them back, the easiest way to control the mouse is with PyAutoGUI. So again, can just use regular pip to install it. That always looks exactly the same. Pip install PyAutoGUI. And this has some, we can use this to control the mouse. So some stuff about the screen. Here's mouse functions. So we have move to, which just jumps to another position, and then the number of time we can, say take 2 seconds to get to that other position, then it'll move nice and slowly to wherever it is. Or move relative, move rel, that's for move relative to our position, which we could also just type .move and get the same thing, but I like to go ahead and type move rel. I find that a little bit easier for debugging. I can remember that it's relative to the position and just how far in the X and how far in the Y is it going to move. each time. So that's the numbers we'll be getting back from the joystick. For drags, I was thinking there's 4 buttons, so maybe just set one of the buttons up to drag stuff. Then we can do different clicks, or we can do click and pass in different arguments, or we could just do right click, middle click, double click, triple click, bunch of different options. And scroll, my original plan when there was only one joystick and 4 buttons was the joystick would move the mouse, and holding down one of the buttons and moving the joystick would scroll. But I think with 2 joysticks, you can just set one joystick to move the mouse and the other joystick to scroll. And it's not on the abbreviated page here, but there's also an H scroll for horizontal scrolling. So we'll use horizontal scroll and scroll, click, drag to, or drag relative. That way we're just relative to our current position every time, and move relative. So those will be the main ones we need. And again, just a quick Google search brought up the API documentations for PyAutoGUI and PySerial. So let's get started coding those up, and then we can just use the mouse on the soft keyboard to get the other half of the input for now. Okay, so we're ready to start typing up the Python here. Just open up a text editor, and we need those libraries we looked at. So, well, I know PyAutoGUI is going to be typing that a lot, so I'm just going to import it this way so I don't have to keep typing that. PyAutoGUI, import everything, and I'll do serial the same way. So serial, import everything. And one spot that the logic for the algorithm will be different between doing it in Python and doing it in PowerShell is if we do it in Python, the microcontroller has to reboot every time the script starts. Whereas if we do it in PowerShell, the microcontroller just has to power up. So we do need to give it time to reboot if we're doing it in Python. So we'll need the time module, which we would probably need anyway. And now I can go ahead and save this. That way the colors change while we're typing things. Where am I going? Libraries, documents, this project, under drivers, a new folder. I'll call it General PC Input. That'll work. And then this will be basic basic control unit.py. There we go. So we've got some color changing now. So with the modules we'll need imported, the first thing we're going to need is an object that can communicate with the serial port. So I'm going to just call that com, and that will be, well, we did the from import, so we don't need to say the module name. And the object is serial with a capital S. So the module is lowercase s, and the object is uppercase S. I've missed that quite a few times typing it in. So the serial object, and we need the COM port, which on my machine here was on COM6, and the baud rate, which when we set up the driver for that, we set that to 115/200. And then there's some other stuff we can pass in, but for now we're just going to do those 2 minimum ones, the minimum we need to communicate. And doing it in Python, it does have to do a full reboot every time the script runs. So we need to give it a little bit of time to do that. So I'll just time.sleep. I'll just delay for 3 seconds for now, and then at some point later we'll refine that to the exact amount to something more exact for how long it takes for the Nano to boot up. But then once it boots up, we should be ready to communicate with it. So we can do com.write and pass in that keyword status and we'll get a result. But remember, when we do this, this is a Python string. This is a large Python object with all kinds of other stuff built in, and we don't want to pass a Python object to our knockoff Arduino Nano. We just want to pass straight Unicode to the Nano, so we do need to convert that to a binary string. If you haven't seen that before, just put a lowercase b before your string, and that converts that casts that from a Python string object into just straight Unicode. And then we can read what comes back. So com.readline. And we probably want to put that somewhere. So let's put that in something called response equals com.readline. And if that's the response we were waiting for from the status, then we're ready to do stuff. So we can just do if response is equal to whatever it's supposed to be at that point. I'm going to go over and copy it from the driver in a second. But if it is that, then we'll just print a successful connection was made. Else, we'll print could not connect. That'll give us a good little starting point. And, well, can't quite remember what the response is. So I'm going to jump over and check the driver on that. So if we come over to our files here, documents, basic control unit, it's in the library, the C++ library, but it was also in that first driver. So I'll just go to the original version, device version 1, and can copy it right from the INO here. Whatever that string was supposed to be. So somewhere in this down here, oh, there it is, status. So if the status is correct, it should return this string, all is good. So copy that and paste that right in here. Whoops, too many quote marks. Just needed the words. So is that the exact string we need? Because we said print line, so it's going to, C++ library is going to print line this. So, well, let's see if this works. I'm going to hit save, and I believe there's a slight change. Well, I know there's a slight change we're going to have to make. I just wanted to include some troubleshooting points along the way. So we think it's this string, so let's run that and give that a try. And, type it in Python. I probably should have just used idle. I can run it from PowerShell. So we need to set location, change to the directory. So first go in documents, and I'm looking up here to see the directory. So documents, under basic control unit folder, /drivers, /general PC input, then, well, I don't need the file name. So we'll go to that directory, and now run the Python file basic control unit.py. Oh, got a typo, misspelled the word import. So just some regular troubleshooting. Oh, should have noticed that because it was the wrong color. Let's come over here and try running that again. Oh, I misspelled import again. Wow. As many times as I've wrote that over the years, you'd think I'd know how to spell the word import. Okay, there we go. And we got a 3-second delay while the machine boots up. The lights are flashing. Uh-oh. Could not connect. So here's that troubleshooting point I was going to talk about. This isn't exactly our response. It's a line, which means there's at least a line break. So why don't we print out the response and see exactly what we have. Print response. Just the general troubleshooting tips. So Control S to save that, come over here and scroll up and run that again. Wait for the device to boot up. There's our response. So for one, it's a binary string, so we should probably be checking against a binary string, not a Python string. All is good. That part looks good. Oh, but then we have a carriage return and a new line. So we could either type those in here or strip them off here. I think I'm going to strip them off here. So a string can always be treated as an array or a list in Python. So we'll read the line and read from character 0 to character -2. So we'll start at the beginning and stop 2 characters before the end, and then we'll just stop before the new line or carriage return comes in. Did I save that? No, I did not. So save that. Now if we scroll up again and run that, the device reboots, and there's our response. We don't need to print that out every time. We'll go remove the echo, and a successful connection was made. So we've successfully connected to our device now. We don't need this echo. That was just for a little bit of debugging purposes there. Take out that echo, and we've made a successful connection. So everything else is just trivial busy work until we get tired of messing with this project. Now what do we want to do? Because we can send our, we know we can reboot the controller, send our keywords or keyword commands, and get the results we expect. So now here in this if part, instead of just printing a successful connection was made, we can do all sorts of stuff and just everything else is just trivial busy work until we get tired of adding functions to this controller. So we'll start, I guess, like we said, the first thing is going to be use this PyAutoGUI library to control the mouse, and then we'll use that on the soft keyboard to handle the typing, and just do our first test of replacing the general input with something more comfortable to use than a generic mouse shape or a flat keyboard. But a successful connection was made, and it is receiving and responding to our keyword commands. So it looks like everything's up and running now. Before we get much further though, there's a slight issue we want to address. So we sent our command and received the response like we expected, but there is a slight issue with that. So I'm going to go over and look at the driver and point out that issue. In version 2, if we open the .ini file for this, what's actually loaded onto the microcontroller, the code we're receiving our response from, down here, well, if something comes down the line, we're going to read it and put it in this string, but in particular, we're going to read string until we hit a new line character. But this command we sent does not end with a new line. We're in Python, so we don't have a write line. We just have a write method, and we have to explicitly state a new line at the end, or a carriage return, or however we have to explicitly state the end of that line. We have to say line break at the end of it. So there's no new line character, which means it's going to read in that string, but then it's not going to process it until it hits the timeout. And we can change what the length of the timeout is and then avoid passing that in every time by just making the timeouts kind of short. I believe it's 1 second by default. But if we run this, it should be quicker when we add the new character in. So I'm going to open PowerShell back up and navigate to that directory, set location, documents, basic control unit, drivers, general PC input, and now run that script. Python basic control unit, basic control unit.py. So when we run this, our device boots up 1, 2, 3. So I think let me run that again and count carefully how long, or try to count carefully how long it took. So when I hit enter, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000. So it actually took a little over 4 seconds that time. And I think that's because there's the 3-second boot up, and then we have to wait on the timeout before it processes this. So if we do a new line there, probably can't tell much difference here, but when we get to the mouse commands, waiting a second for the next mouse command would definitely be noticeable. So save that and run that again. 1, 1,000, 2, 1,000, 3, 1,000. So that time it was just barely over 3 seconds instead of a little over 4 seconds. So you can see it is noticeably quicker. And if we had to wait for a whole second for a timeout on a mouse command, it would be far, far more noticeable. So we could either set the timeout to be very short or just add in the line break at the end of all of our keyword commands. So that's kind of important. You want to make sure every time we pass a string, pass one of our commands in, it is a binary string, not a Python string, so just a lowercase b before it. And same thing with the result we get back. Make sure we're dealing with the right type of strings, and make sure all of our keyword commands end with a new line. Otherwise, there might be a long wait. So now we're ready to fill out functionality until we just get tired of adding functions for testing it and feel confident that everything works like expected.